Hey guys, my name is Jin, and I'm today for this whole playlist I'm gonna lecturing calculus. The textbook I'm choosing is the Steward Calculus book. Okay, and then what we're gonna do is just teach lecturing from section by section. Hopefully I can get through this book. Yeah, so today we start chapter 1, section 1, with dealing with function right here. So definition of function: f, we give a name of the function. F is a rule that assigns to each element of x in a set of D that exactly one element called fx in a set of E. So basically we have two sets, D and E. Okay, and the function is a rule that assigns in between, and you will see. Now I'll show you this diagram. Alright. So we have D, we have E. Two sets. D for x, and E for fx. Okay? And D are the numbers. You're gonna put it in based on the rule. You calculate the numbers, you get the E, you get the result from E. Right? So the rule is a function. You can fx, my example is fx equal to x squared. You can have x equal to x plus 1, negative function, exponential function, logarithmic function, anything you can think. Right? You put it in, and you have the input, the numbers you're going to input in. If I put -1 in, -1 squared give me 1. Okay. If I put 0 in, 0 squared give me 0. If I put 1 in, 1 squared give me 1. Okay. And you kind of can see that E is a number that being calculated based on the D. Right. It's a result of the D by following this function. Right. So E is called dependent variable. So E is called dependent variable because it depends on the one numbers. And the D, it also depends on what kind of function we're using. But D is not. So D is not. D I can put number. I can choose to have all kinds of numbers I can use. Right? So D is independent variable. Okay? So D, E connected with function. Good. Okay. Now let's talk about compare with something that is not a function. Okay. So it's not a function. It looks similar. We also have the D and E. There's also a function in between. But what makes difference? If you look at the definition really carefully, because it says each element of x inside of D that gives only exactly one element for fx. Do you see that? Right. So here's the D, here's the function, here's the E, right? However, if I put 1 in here, okay, because my function is plus minus radical x, plus minus square root of x. Okay, either way you can call it. If I put 1 in here, since I have positive and a negative, alright, positive and negative, that means I got positive 1. If I put 1 in here, that's positive 1 and negative 1, because I have positive and negative. Alright, if you look at it again, each element x 1, that only gave exactly one element, but I have positive 1 and negative 1. I have two. So therefore this is not a function. This fx equal to positive and negative radical x is not a function. Okay? But how do I make it as a function? Since I have positive and negative. Oh, how about I just separate them? Because it has two things, it has two signs in it, right? I separate them. I can separate them. I separate them. I have this function fx equal to positive square root of x. I have the second function fx is equal to negative square root of x. Okay, I got this. If I put d in here, 1 give me 1 because it's positive. If I put 1 in here, I get negative 1 because this is negative. Right? Two functions combined together give me the same result as the top one. However, this is not called as function. This is not a function. I need to write it as two separate parts. Do you guys see that? This is not a function. Those two are the functions. Okay? If you learned geometry before, we know 2 points can draw a line. If we graph the function, we can see there another way of showing it. We're going to use another, it's called vertical line test, because we have positive 1 giving 1, this is a point, positive 1, negative 1, this is another point. We know 2 points can form a line. If you can see them, we're going to use this vertical line test. This is my vertical line test definition. If a curve in the xy plane is a graph of a function of x if and only if, sometimes you write it as professor, sometimes you write it as IFF, short version, abbreviation. No vertical line that intersects the curve more than once. Okay, more than once. No more than once. Exactly one. They kind of refer to each other, right? Why? Now I show you. Remember, this is a function, this is not a function. Okay, if I have this function, if I draw them, if you draw it, right, the graph is, it looks like this. It's kind of like, looks like this curve up, and I draw a vertical line, and those vertical line can only cross a function with one intersection. Like here I got one intersection, here I got one intersection. I can draw more, but it's not necessary. Showing case, this can only intersect one time. Okay, so this, graphically speaking, because it only intersects once, it is not a function. Here, for this one, graphically speaking, if I do the intersection, I have only one point intersection at this 0, 0. Right? For 0, 0, I can only see one intersection because there's only a point here. There's nothing else. But at other points, like right here, and like right here, I got 2 points. That makes it, it's not a function. This is it, because we have 2 intersections. Because no vertical lines intersect the curve more than once. That means we cannot intersect more than once, right? And remember, we did split this function, which this is not a function, right? This expression by 2. So to make the each individually to become as a function, if you look at the graph, the top part is the positive and the bottom part is the negative part. If I cover it, do you see it? If I cover it, this curve is the top part that only intersect once on these 2 lines. That makes it a function. Same thing. If I cover the top, and for the bottom, it can only intersect once here and once there. That makes this negative function, negative square root of x, also become as a function. But together, it is not a function. We need to set them 2 separate times, 2 separate pieces. Okay, so that is the function. Now we have this rule being set up. But we also have the two sets we're going to dealing with, because the function is the set of D and the set of E, right? The X for set of D and the f(x) the set of E. For now, we give the name for each of those two variables, for each those two sets. Okay, so for this set D, we call it domain, which is all the possible numbers that X can be, which is like positive number you can put in there, decimals you can put in there, negative numbers you can put in there, even variables, not just numbers, because I'll show you a case. If you see right here, this is A. Sometimes this is A, but if you learn later on, this is called constant. It's not really A, it's just A. It's a letter, but it represents some numbers. We don't know, but we call it constant. But right here, E is called the range. It's all possible number f(x) can be. Okay. So for this type of function, because domain and range are only dealing with f(x) and f(x), for function we're not necessary to have this connected equal sign. Okay, we can just have the visual expression to see it like domain and range, two sets right away. Okay, we're gonna have just those two sets. We're gonna just have the two sets. For one, I have -1. For A, I have B. For Y, sorry, this is pi, my bad, I have another pi. You get what I'm saying? So domain and range, domain and range, and domain and range. Okay, and it's just a connection, interaction between one resulting to another, one resulting to another, one resulting to another. Okay, so this way of showing it, a function by connecting an element of domain to element of range is called arrow diagram. Okay, and we're still talking about functions, and we're still confused about functions and other function. If we have these two ways. Alright, now which we check for this kind of expression, we just drawing a diagram. Okay, let me tell which this is function and this is not function. Okay, for A, if I put A in here, that give me X. If I put 1 in here, that give me 2. If I give me B in here, that give me C. Sorry, this is not an X, this is a C. My bad. Alright, this is a C. So for A, I got the C. For 1, I got a 2. For B, I got the C as well. Okay. But for here, I have 1, give me 1, and 2. Remember the definition of function? If I have 1x, I only have exactly one element to show for. I got 2. So this is another function. If you compare those two right here, A and B all going to C. However, C is only come from A. When you put A in here, you only get 1 C. When you put B in here, you only get 1 C. It's not like 1, you got 2 numbers result. So it's from the origin of the A, you draw 2 arrows out, that is not function. C, you have 2 arrows goes in, that is okay. Hope you guys didn't understand it. It's a function, domain, and range. See you next time.